Hello everyone, welcome back to Let's Do Mathematics. In today's video, we are going to solve 10 important limits using the rationalization method. This method is very useful whenever we have square roots or cube roots in the numerator or denominator, and direct substitution gives us indeterminate forms like 0 by 0. So let's begin. We have first example. So direct substitution gives in numerator under root 1 plus 0 square minus 1 0, that's 0 since this is 1 and 1 minus 1 is 0. And now in denominator 0, so x is equals to 0, so thus this is 0 by 0 form. So we multiply numerator and denominator by a square root of conjugate of under root 1 plus x square minus 1. So conjugate of under root 1 plus x plus x square minus 1 is under root x square 1 plus x square plus 1. So this limit, thus we can write this as square root 1 plus x square minus 1 multiplied by under root 1 plus x square plus 1. This is the conjugate, and now this is x times under root 1 plus x square plus 1. Now we can write this as limit x tends to 0. This is under root 1 plus x square whole square minus 1 square over x times under root 1 plus x square plus 1. So this is equals to limit x tends to 0 1 plus x square minus 1 over x times under root 1 plus x square plus 1. Now this is equals to limit x tends to 0. This 1 and 1 gets out to be cancelled, and we can take x as a common factor. So this x times 1 plus x and denominator is x times under root 1 plus x square plus 1. So this x and x gets out to be cancelled. Now we can write this as limit x tends to 0 1 plus x over under root 1 plus x square plus 1. Now we can put x is equals to 0. So if we put x is equals to 0 in denominator and numerator, we don't get any indeterminate form. So putting x is equals to 0, this is 1 plus 0 over under root 1 plus 0 square plus 1. So this is 1 over square root 1 plus 1, and this is 1 over 2. So this is the answer of the first question. Now let's move on. Second question. So second question is limit x tends to 0. So second question is limit x tends to 0 2x over the square root of a plus x and minus square root of a minus x. In short, if we put x is equals to 0, this is 2 into 0 under root a plus 0 minus under root a minus 0. So this is 0, and this is a square root of a minus a square root of a, so 0 by 0 form. So this is 0 by 0 form. Now we again multiply by conjugate of this denominator. So conjugate of this denominator is the square root of a plus x plus the square root of a minus x, and again this is the square root of a plus x plus the square root of a minus x. So this is limit x tends to 0 2x times under root a plus x plus the square root of a minus x over this is the square root of a plus x whole square minus the square root of a minus x whole square. So this quantity limit x tends to 0. So this is equals to 2x times under root a plus x plus the square root of a minus x, and this is numerator is a plus x minus a minus x. Now this quantity is equal to limit x tends to 0 2x times under root a plus x plus under root a minus x over this is a plus x minus a plus x, and this a gets out to be cancelled. Now this is x tends to 0 2x times under root a plus ax plus under root a minus x, and this is 2x. So this 2x gets out to be cancelled. Now we have limit x tends to 0 under root a plus ax plus under root a minus x. So if you substitute direct x is equals to 0, then there is no any indeterminate form, so we can do it. So this is under root a plus 0 plus under root a minus 0. So the value of limit is 2 times under root a. So this is the answer of the this problem. Again, let's move on the third problem. So we have third problem is, this is limit x tends to 2 and square root of 3 minus x minus 1 over 2 minus x. If we put x is equals to 2, this is 3 minus 2 minus 1 over 2 minus 2. So this is also 0 by 0 form. So this is in indeterminate form. So direct substitution gives us indeterminate form. So again we use rationalization method. So limit this is equals to limit x tends to 2, 3 minus x minus 1 over 2 minus x, and we multiply in numerator and denominator by with conjugate of this. So conjugate of this is square root of 3 minus x over square root of 3 minus x plus 1. Now this quantity is limit x tends to 2. This is square root of 3 minus x whole square minus 1 square over 2 minus x times square root of 3 minus x plus 1. So this is equals to limit x tends to 2. So this is 3 minus x minus 1 over 2 minus x times under root 3 minus x plus 1. So now again this is equals to, this limit is equals to limit x tends to 2. This is 3 minus x. So this is by simplifying in numerator. If we simplify in numerator, this is 3 minus 1 is 2. So this is 2 minus x over 2 minus x times under root 3 minus x plus 1. So this 2 minus 2 minus x gets out of cancelled, and now we can substitute directly. So this is 3 minus 2 plus 1. So this is 2. So 1 over 2 is the answer of this problem. Again, we have another problem. So the answer of the third problem is 1 over 2. Now we have another fourth problem is so this is the third solution of the third problem, and fourth problem is limit x tends to 0. Fourth problem is limit x tends to 0. The square root of x minus 1, square root of x minus x over x, square root of x. So this is the homework for you. Again, let's move on the fifth problem. So fifth problem is square root of limit x tends to 0, square root of a plus x minus square root of 8 over x square root of a square plus ax. If we put x is equals to 0 in numerator, we get a plus 0 minus a, and this is 0 times under root a square plus a times 0. So this is also in 0 by 0 form. So we can now we use rationalization method. So multiply limit x tends to 0, multiply by conjugate of this quantity. So conjugate of this quantity is a plus x plus the square root of a over x times the square root of a plus x plus the square root of a times, and this is under root a square plus ax. Now this can be written as, so we can write this as limit. So this is limit x tends to 0, a plus x minus under root a square over x times under root a plus x plus under root a times under root a square plus x. Now this is equal to, again this is equal to limit x tends to 0. This is limit x tends to 0, a plus x minus a over this is x under root a plus x plus under root a and under root a square plus ax. Now this a and this x gets out to be cancelled. Now if you put x is equals to 0 in denominator, there is no any indeterminate form is obtained, so direct substitution is permissible. So this is under root a plus 0 plus under root a, and this is under root a square plus a times 0. So this is answer is under root a plus under root a, and this is the square root of a square. So answer is 1 over 2a times under root a. Thus this is the answer of this problem. Now we have next problem 6. So this problem 6 is if we put x is equals to 1 in numerator, we get 3 plus 1 minus under root 5 minus 1. So this is 4 minus 4, this is also 0, and in denominator 1 square minus 1 is also 0. So this is 0 by 0 form. So we can again we use rationalization method, limit x tends to 1. So this is 3 plus x minus under root 5 minus x, and this is x plus 1 times x minus 1. Now if we multiply 3 plus x plus under root 5 minus x, so this is under root 3 plus x plus under root 5 minus x. Now we can write this as limit x tends to 1. This is 3 plus x whole square minus under root 5 minus x whole square over x plus 1 times x minus 1, and this is under root 3 plus x plus under root 5 minus x. Now this quantity can be written as in numerator, this is limit x tends to 1, and this is 3 plus x minus 5 minus x. So this is equals to 3 plus x minus 5 plus x, and this is equals to x plus 1, and this is x minus 1 over under root 3 plus x plus under root 5 minus x. Now let's move another in further steps. So this is limit x tends to 1, and this is in numerator we have obtained this is 2x minus 2. So this is 2x minus 2. 2x minus 2 can be written as 2 times x minus 1 over x plus 1 times x minus 1, and this is under root 3 plus x plus under root 5 minus x. Now put this x minus 1 gets out to be cancelled, as so indeterminate form has been removed. Now we can put x is equals to 1 in the limit. So this is 1 plus 1, and this is under root 3 plus 1 plus under root 5 minus 1. So this is 2 over 2 times under root 4 plus under root 4. So 2 gets out to be cancelled, and this is 2 plus 2, and this is 1 over 4 is the answer. Now thus we have understood in this video that how can we apply the indeterminate rationalization method to obtain the limit. So again we have another problem is, so limit 2 minus under root x over 4 minus x, we can again we multiply by conjugate 2 plus under root x and 2 plus under root x, and we can apply by previous methods, we can find out this limit. So I will left this problem for you. Again next problem is 8. 8 is again the same 8 problem can also be solved by another previous methods. So you can use those methods to obtain. So I will also left this problem, and for hint, if you x square, if you x square can be written as x times x minus under root x, and this if we take under root x as a common, so this is x under root x minus 1, and this is under root x minus 1 in denominator. So if and x tends to 1 means x minus 1 is equals to 0. So under root x minus 1 is 0. So you have to cancel this term. So cancelling out this term you get, and now you can if you take under root x is equals to t. So x is equals to t square. So this is x is equals to t square. So this can be written as limit x tends to t tends to 1, and x square is t raised to power 4 minus this is t, and this is t minus 1. So this is limit t tends to 1, and this is t cube minus 1 over t minus 1. Again we can write this as limit t tends to 1, t times t minus 1, t square plus t plus 1 over t minus 1. So this t minus 1 gets out to be cancelled, and now we have obtained a simple limit t times t square plus t plus 1, and if we put t is equals to 1, we get directly answer of this problem. So this is the Answer is 1 into 3. This is 3. Thus, we have another problem. Ninth problem is again can be solved by those previous methods. So this is a very simple method, simple problem. Thus, we have solved, and I have left 3 problems to solve you. And I hope this video, I hope you have understood this method. And that's it. We have successfully solved uh, 5 or 6 limit problem using rationalization method. And I hope this video helps you understand how to tackle indeterminate forms using conjugates. If you found it helpful, don't forget to like, share, and subscribe to Let's Do Mathematics for more such videos. See you in the next one. So thank you.